Hello everyone, welcome back to my channel. Today's is the session where we are going to end the Boolean Algebra chapter. Okay, so today's topic is product of sum reduction using K-map. In the last session, we had seen some example on how to reduce a sum of product expressions using K-map. Right, so today we are learning all about product of sums. Now, in a product of sum reduction or a POS reduction, each square of a K-map represent a max term. Okay. Now, for POS reduction, map is filled by replacing zeros in the squares whose max term lead to output 0. So I'm sure that very clearly you can see the difference here. In the sum of product, we were filling ones, isn't it? But here we are going to fill in the zeros, and also see how we are going to write the K-map. So this one is the given example here is for two variable K-map. So see here, the values 0 and 1, 0 and 1, the box values, everything is same, but except whenever the value is 0, we are taking it as A, not the complement, okay? Wherein which in the sum of product, we were taking a 0 value as a complement of a given variable, isn't it? So see here, whenever there is 0, we are taking it as a variable itself, but whenever it is 1, we are taking it as its complement. And also, the values here is the or of two variables and not and. So whatever the values are here, they are going to be odd value of A and the B. That is the row value and the column value. Fine. So this is how we are going to represent the two variable K-map. Let's see how do we represent a three variable K-map. So three variable is going to be something like this. So see the numbering is going to be the same, okay? So here it is going to be 0, this is 1, this is 0, 0, this is 0, 1, this is 1, 1, and this is 1, 0. Only the difference is wherever there is 1, we are going to write a complement, and wherever there is 0, we are not going to write the complement. That's all the difference is. But even these box values are going to remain same, right? And here we are going to, as I said, we are going to OR the values. Okay, so here if it is x, we are going to x plus y plus z. Okay, so this is how we are going to represent a three variable K-map. Let's see the four variable. So this is a four variable. See the values here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, isn't it? So those values are going to be same. The difference is we are doing the OR operation between the variable, and also wherever there is 0, we are considering it as a non-complemented variable, and wherever there is a value 1, we are considering it as a complemented variable. Okay, I hope there is no confusion now. Now, let's see the steps involved in reducing a POS. So, first things, prepare the truth table for the given function. Okay. After that, draw an empty K-map for the given function. It may be for two variable, it may be for three variable, it may be for four variables. Next, we are going to map the function by entering zeros. Okay, so here we are entering zeros, not the ones. Then enter ones in all the left out empty squares. Okay, so wherever there is no zero, we are going to fill them with ones, and then we are going to encircle zeros here. Okay, and then remove the redundant groups. This is the similar steps. Write the reduced expression and then and them. Okay, so what is a different thing we are doing than SOP here? First thing is we are noticing the zero value is taken by non-complemented variable and one value is taken by the complemented variable. That is the very first difference. Then we are going to add the variables, and then the third one is we are entering the zeros and then we are encircling the zeros. Okay. Rest all the rules, whatever the rules are there for encircling, whether it is about octet, whether it is about quad, pairs, they are all going to remain same as our SOP reduction. Right. Now this example here we have, it is saying reduce the following K-map in product of sum. So they have mentioned here product of sums, isn't it? Now let's write the values here first. Now we know that for 0 it is an uncomplemented variable, and for 1 it is a complemented variable. Similarly, let me write here. So this is going to be b plus c, b plus c bar, b bar plus c bar, B bar plus C. So don't forget to write the plus here because this is nothing but our product of sums. Okay. Now next, what we are going to do? We are going to encircle the zeros. Okay. So I will encircle this. Then I will encircle this and I will encircle this. So looking at this, can you feel that there is a redundant group? Isn't it? So this particular pair has zeros, but both the zeros have been taken by the other pairs also. So this is what? This is a redundant pair. I hope you remember we have learned about redundant. So there is no need of this particular pair. I can remove it. Right. Okay. Now let's go ahead and write the values for this pair. What is the value for this one? It is going to be, the row value is changing from A to A bar. So I don't have to write A. Okay. So column value is single. Hence I can directly write B plus C. Isn't it? What is it going to be for this one? So the row value is A plus, and then this is B plus C bar is changing to B bar plus C bar, isn't it? So B is changing state here from B to B bar, hence I can ignore B. I'm left with C bar. Okay. So hence the reduced expression for this particular K map is going to be B plus C and A plus C bar. Okay. Fine. So next, let's see another example. Now they have mentioned here, find the minimum POS expression of. So whenever you see pi, even if it is not mentioned this, you should understand that this is POS. Okay. So we have a 4 variable K map we need to draw. So let's draw that. We need a 16 square. Right. Why 16 square? Mainly because we have 4 variable. We need a 16 square. So 1, 2, 3, 4. 1, 2, 3, 4. How do we write the values in this? So let's write, it's going to be A, B over here and C, D here, isn't it? So this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Let me write the square values also. So it is going to be easy if we write the square values. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. Now, let's fill in the values. Okay. So 0. So 0th square, I'm going to fill 0 here. Okay. So don't forget we are filling 0, not ones here. 1. So 1 is going to be 0. 1 is this value. 3 is also going to be 0. Then we have 5. Then we have 6. Then we have 7. Then we have 10. Then we have 14. Then we have 15. Right. Now, how are we going to pair them? Pair them. So first, let us find out if there is any octet possible. There is no octet possible even if we are using the rolling of the map method. But then we have quad which is possible. Okay, so I'm doing a quad here. I'm doing a quad here. And then I am left with this one which I can encircle over here. Another 0 is left here. Let me encircle it with this. Okay. So we have encircled all the zeros. Now directly we can write the values. So before that, let us write these values. It's going to be AB, AB bar, A bar, B bar, and A bar, B, isn't it? And here it is going to be, sorry, there has to be a OR operation between them. Okay. So let me write again. This is going to be A plus B, A plus B bar, A bar plus B bar, and A bar plus D. So this is going to be C plus D, C plus D bar, C bar plus D bar, and C bar plus D. Right. Now first, let us write the value for this particular quad. What is it going to be for this one? So the row value is changing from A plus B to A plus B bar. So B is changing state, hence I'm going to write only A over here. And the column value is C plus D bar is changing to C bar plus D bar. So C is changing state. So I'm going to write here D bar. Okay, let's find out for this one, this chord. So here the row value is a plus b bar is changing to a bar plus b bar. So what is changing state here? A is changing state. So I'm directly going to write b bar plus c bar plus d bar is changing state to c bar plus d. Okay, so d is changing state here, hence I'm going to write only c bar. Let's find out the pair value here. Here the row value is a plus b, which is going to be the same because there is no transition happening, and the column value is changing from c plus d to c plus d bar. So d is changing state, hence I'm only writing c here. Okay, now let us find out the value of this one. So what is happening to the row? A bar plus b bar is changing to a bar plus b. So a is remaining same, b is changing state. And here, since it is a one column, I can directly write these values. Now let us and them together. So what are the values? A plus B plus C into A bar plus C bar plus D into A plus B bar into B bar plus C bar. Okay. So this is our final expression for this given schema or this given question. I hope it is clear. Now, let's go ahead and see one more last question. Okay, so this is the given question. Use K-map to reduce using POS form. Okay, so again we need 4 variable K-map. So let's draw that, a 4 variable K-map. So we need 16 squares. 1, 2, 3, 4. 1, 2, 3, 4. Now, let's write the values. It is going to be A, B, C, D. Okay. Let me write the square values. Okay. So prepare your K-map always like this. It is going to be very helpful to you. 8, 9, 10, 11, 12, 13, 15, 14. Okay. This is going to be 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. In other words, A plus B, A plus B bar, A bar plus B bar, A bar plus B. Okay. C plus D, C plus D bar, C bar plus D bar, C bar plus B. Right. Now let's put the values into the K-map. What are those? 0. So 0 to square is going to have the value 0, 2, 4, 6, 8. So 2, 4, 6, 8 and then 10, 14. So 10 and 14. So how are we going to do this? Right. Let's pair them. We know that we can do a quad over here. Right. Then I can do we can do another quad over here, isn't it? So let me do a quad. This one, I can do the map ruling and attach it with this one, isn't it? Now, again, I can do a quad over here. Let me change the color. Then it will be easy to understand. See over here, what am I doing? I'm going to map this, 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 and this. Right. Now first let us write the value for this quad. So what is it going to be? A plus B is changing state to A bar plus B. So A is changing the state. I am writing B first. And then what is happening here? C plus D is changing state to C bar plus D. So D is remaining same. So I'm going to write D over here. Okay. Next, I'm finding for this particular quad. Okay. Now I'm finding value for this particular quad. So what is happening? Remember this and this one I'm talking about. So A plus B is changing state to A plus B bar. So B is changing state. Hence I can write A plus. Here C plus D is changing state to C bar plus D. Hence C is changing. D is remaining same. I can write A plus D. Now let us write for this one. Single column one. So we know that for this entire thing the value is going to change. But only remaining will be C bar plus D. Okay. Now the final reduced expression for this particular question is going to be a plus d into b plus d into c bar plus d. I hope this is clear to you all. Okay. So these are the three examples about how to reduce using how to reduce a POS form using a K-map. With this, we have come to the end of this particular session, and also we have come to the end of this particular chapter itself. Okay. So next, I will be coming up with the new videos. The next lesson, what we are going to learn is logic gates. Okay, students. Till then, thank you for watching. Take care.